Hello Year 10. This video is just to run through the work for you to do this week. So this is a review of work that we've already done, so you can go back and you can watch the first video I made where I explain this in a lot of detail, whereas this video is just going to be just to give you some guidance on how to answer these specific questions. So the first question is about ethene, C2H4. Now these four questions here are all very easy. You shouldn't have any trouble answering those. And then using the information from these four, you should be able to answer number 5. Now when I say draw the displayed formula, what I mean, I'm not going to tell you what the displayed formula for ethene is, but I'll tell you what the displayed formula for methane is. Now methane is CH4, and when I talk about a displayed formula, I mean this. Okay. And it's important that you can do that because then from this you can see how many of each type of bond there is. So I can see that in methane there are 4 carbon-hydrogen bonds. Okay, and the information here will help you draw that formula. Now remember, there might be single bonds, there might also be double bonds in there. Okay. Section number 2, write a balanced symbol equation including state symbols to show this reaction. So it's ethane combustion with oxygen. All right. Now remember, oxygen is O2, and combustion is the reaction with oxygen. To produce 4 compounds that have carbon and hydrogen, they will produce carbon dioxide, and they will produce water. Now, it's very, very important that your equation is balanced. All right. Otherwise, when you count the number of bonds, you won't get the right answer. So, for example, if we did the combustion of methane, so methane is CH4 plus O2 goes to make CO2 plus H2O. Now, I can draw the displayed formulas underneath each one. Remember, oxygen is that, and carbon dioxide looks like this. Okay, now if I was just to use that picture, I'd get the wrong answer because that's not a balanced equation. All right, I've got 4 hydrogens here, but only 2 here. So I need a 2 there. And now I've got 2 oxygens and 2 more oxygens, gives me 4, so I need a 2 there. So really, it should be this. And now I can count the number of bonds that I have. All right, so here for number 8 and number 9, if you don't have the balanced symbol equation, you won't get the right answer. All right. Okay, so I think the rest of that's fine. Now, ethene reacts with water to make ethanol. And I'm going to be very nice and I'm going to tell you what I'm not going to tell you what the balanced symbol equation is, but I will tell you the displayed formula. Actually, no, I won't. I'm not going to tell you that because that's one of the questions that I've made choices for that question, so you should be able to work that out. So I'm not going to tell you that, but I will tell you down here this one. I will tell you the displayed formula for chloroethane. So chloroethane looks like this. Okay, which makes sense because, I mean, you've already worked out how many bonds hydrogen and carbon can form. And chlorine, well, chlorine is in group 7, so it needs 1 extra electron. So it's only going to form 1 covalent bond because that 1 covalent bond will allow it to gain that extra electron. All right. But I think the balanced symbol equation is very, very easy for that. As long as you know what the formula for hydrochloric acid is, which you should know, which is why I'm not going to tell you what it is. For section 5, same again. I think you should know what the formula for chlorine is, which is why I'm not going to tell you that. I'm also not going to tell you the formula for dichloro. So I'm not going to tell you the displayed formula. I'm not going to tell you what dichloroethane looks like because I think from this you should be able to work out what dichloroethane looks like. Now, this question question 19, I mean, essentially, so just going back, you've got one less hydrogen and one more chlorine. All right, if you can't work that out, I think it should be straightforward. Question 19 is similar but slightly different to the questions we did last time. So if we look at this, the total energy change for the reaction is -184. Find the bond energy for the chlorine-chlorine bond. All right, so what I'm doing now is, rather than give you all of the bond energies and ask you to work out the overall energy change, I'm giving you most of the bond energies and the overall energy change, and you need to work out one bond energy. So I can illustrate this with an example. All right, so let's go back to our combustion of methane example. Now, normally we would add up all the bonds over here. If we draw a line on the middle, add up all the bonds over here, add up all the bonds over here, do these bonds minus these bonds, gives us our total energy change. All right, let's not do that. Let's say that perhaps we don't know the carbon-hydrogen bond energy and we want to find it. All right, now we do the exact same thing. So we do 4 times CH, 2 times OO, 2 times CO, 4 times OH. Okay, and we can write out what all these energies are. Now I don't know what this is, so I'm going to write 4x. All right, and that's what you need to do here, but for the chlorine-chlorine bond. Now the other ones, I'm going to say that I know what those all are. So oxygen is 498. So that's 2 times 498. Carbon oxygen, that's 805. So 2 times 805. And oxygen hydrogen is 464. 4 times 464. Now I can add those up in the usual way. So here I get 4x plus 2 times 498 is going to be 996. And over here I'm going to get 2 times 805 is 1610 plus 4 times 464 is 1856. So these two added together is 3466. Okay. Now, up until now, we would always have done this minus this. So if I do 4x plus 996 minus 3466, that gives me my total energy change. Now, if I had told you at the start that the total energy change for this reaction is total energy change equals minus 818 kilojoules per mole. What I can do now is, instead of working this number out, I write it in here, minus 818. And now I solve for x. All right, so I can see that 4x is going to be, well, it'll be minus 818 plus 3466 minus 996 gives me 1652. Okay, and then I just need to divide by 4 to give me 413. X equals 413 kilojoules per mole, which is the number here. All right. So when you get to this question here, question 19, this is the tricky sort of one, but that's how you do it. All right, you follow the same process to do it like that. And then section 6, carbon. I'll be very nice. I'm in a very generous mood today. Carbon. Okay, no problem with the symbol equation. Dot and cross diagrams, that's old stuff. You should be able to do that. Okay, this is a intermolecular bonding question. This is an intermolecular bonding question. This is a detecting gases question. If you're not sure about that, then you can read pages 94 to 95 of the textbook on Caboodle. Predict whether the reaction of carbon and oxygen is exothermic or endothermic, easy. And then just calculate the energy, which I think actually for that one is probably going to be very, very straightforward for you. All right, and that's it. So enjoy.